Assalamu alaikum. Welcome, dear students, to a new physics lesson, Chapter 15, Rectilinear Motion, Part 1. By the end of this lesson, you will be able to distinguish the different types of rectilinear motion, determine the characteristics and the time equations of uniform rectilinear motion, determine the characteristics and the time equations of uniformly varied rectilinear motion, UARM and UDRM. Determine graphically the distances covered by a moving object using the area method. In this video, we are interested in the first objective. In the previous chapter, Description of Motion, we have learned to describe the rectilinear motion of an object along x-axis using the position vector, r vector, which is equal to OM vector, which is equal to xi vector, where the norm of OM vector is equal to the distance covered between the points O and M. The velocity vector v equal vi, where v equal delta x divided by delta t, which can be positive or negative, indicating the direction of motion, and the acceleration vector a vector equal ai vector with a equal delta v divided by delta t, which can also be positive or negative, indicating if the speed of the object increases or decreases, and indicating whether the motion is accelerating or decelerating. In this lesson, we will study rectilinear motion. Rectilinear motion is the motion along a straight line. The straight line could be horizontal, vertical, or oblique. In this lesson, we will study three cases of rectilinear motion depending on the variation of the speed. We will study uniform rectilinear motion URM, uniformly accelerated rectilinear motion UARM, and uniformly decelerated rectilinear motion UDRM. Let's start with studying uniform rectilinear motion. A driver moving at a speed of 12 meters per second continues moving at an empty straight road with the same speed. During its motion along a straight path, the driver's speed remains constant, which is equal to 12 meters per second. If we photograph the positions of the driver after equal intervals of time, we clearly notice that the driver covers equal distances during these equal intervals of time. Let's record the instantaneous speed of this driver after those equal intervals of time. Note that the speedometer is used to record the driver's instantaneous speed, and a stopwatch is used to record equal intervals of time. The recordings are tabulated as shown. From the table, we can see that the instantaneous speed is recorded each 5 seconds, where its value remains constant. Then, the variation in the instantaneous speed is zero, which means that the driver is neither accelerating or decelerating. In other words, the acceleration is equal to zero. This type of rectilinear motion is known as uniform rectilinear motion. Note that if you are asked about the instantaneous speed at any instant during the uniform phase, for example, at 20 seconds, where the driver is still moving with a constant speed, then the answer will be simply 12 meters per second. Then, in a uniform rectilinear motion, the trajectory is a straight line, and that's why we call it rectilinear motion. The speed remains constant, and the object covers equal distances during equal intervals of time. Let's move now to the second type of rectilinear motion, which is uniformly accelerated rectilinear motion, or simply UARM. The motor is initially at rest. When the green light of the traffic sign turns on, the driver speeds up where its speed increases to a certain value. We say that the driver accelerates. If we photograph the positions occupied by the driver after equal intervals of time, we can clearly notice that the distance separating two consecutive instants is increasing. Let's record the instantaneous speed of the driver in this case, where the speeds are recorded after equal intervals of time. The recordings are tabulated as shown. The table showed that the speed increases from 0 to 9 meters per second in 15 seconds. In the previous lesson, we called such type of motion where the speed increases accelerated motion. But let's have a closer look on the increase in speed. From the table, after 5 seconds, the speed increases by 3 meters per second. Also, after another 5 seconds, the speed increases by 3 meters per second, where it becomes 6 meters per second. Then from the table, we notice that during equal intervals of time, in our case 5 seconds, the increase in speed is constant, which is 3 meters per second each 5 seconds. Since the increase in speed is constant, then we will call this motion uniformly accelerated motion, where the term uniformly does not mean that the speed is constant. It means that the increase in speed is constant. And of course, it is uniformly accelerated rectilinear motion since the trajectory is a straight line. In a uniform accelerated rectilinear motion, if you are asked to indicate the value of the instantaneous speed after equal interval of time, that is at t equal 20 seconds, which means after 5 seconds, since the increase in speed is constant, then the instantaneous speed will increase by 3 meters per second in our case, which means that it will be 12 meters per second. As a conclusion, in a uniformly accelerated rectilinear motion, the trajectory is a straight line, the speed increases with a constant rate, and that's why we call it uniformly accelerated and not just accelerated motion, and the distance covered by the object increases during equal and successive intervals of time. Let's move now to the third type of rectilinear motion, which is uniformly decelerated rectilinear motion. If the driver is moving at a certain speed, 12 meters per second for example, and observe that the light of the traffic sign turns red, he applied the brakes until he stops. In this case, the driver's speed will decrease until it becomes 0. When taking photographs for the driver's position after equal time intervals, we can clearly notice that the distance traveled by the driver in these equal intervals of time are decreasing. The instantaneous speed of the driver at different instants, separated by equal time intervals, are recorded and tabulated in the following table. When analyzing the results of the table, we can notice that the speed decreases by 4 meters per second each 5 seconds. Then, the motion is uniformly decelerated since the decrease in speed is constant. Then, in a uniformly decelerated rectilinear motion, the trajectory is a straight line, the speed decreases with a constant rate, and the distance covered by the object decreases during equal and successive intervals of time. Then, as a conclusion, the driver passes by 3 different phases during its motion. It follows a uniformly accelerated rectilinear motion as it increases its speed uniformly from 0 to 12 meters per second. Then it moves with a constant speed where its motion is a uniform rectilinear motion. Then it decreases its speed uniformly and the motion is said to be a uniformly decelerated rectilinear motion. Now let's practice by solving the following application. Don't forget to pause the video and try to solve it by yourself. The adjacent graphs correspond to a rectilinear motion and represent the variation of the speed with respect to time. Determine with a justification the type of the motion in each figure. In figure 1, the figure represents a uniform rectilinear motion since the speed is constant during time. Figure 2 shows that the speed increases linearly with time. Then, figure 2 represents a uniformly accelerated rectilinear motion. Figure 3 represents a stationary object. The object is at rest since the speed is null. In figure 4, the speed decreases linearly with time. Then, the figure represents a uniformly decelerated rectilinear motion. To summarize the ideas of this video, we have studied the 3 types of rectilinear motion, where in a uniform rectilinear motion, the object is moving on a straight line, the instantaneous speed is increasing with a constant rate. In a uniform rectilinear motion, the object is also moving on a straight line, but the instantaneous speed is constant during the time. And in a uniform decelerated rectilinear motion, the object is moving on a straight line and the instantaneous speed is decreasing with a constant rate. This is the end of part 1. Thanks for your attention.